Good morning and welcome to my channel. Here on this table I put plants that belong to the same family. They all belong to the family Cactaceae. To tell you more about these plants, let me start with this plant. This is Pereschia. In nature, it can grow to be a big shrub. Actually, it's a very beautiful plant. This specimen, my plant, is quite drabby, and I hope to make it into a beautiful plant at one point. It is as it is right now, but it should have nicely, brightly colored leaves, just like this one, with pinkish color. Well, it will be nicer at one point, but nevertheless, it's very interesting because it looks very much like the common ancestor of all these plants. Okay, so the common ancestor of all Cactaceae looked a little bit like this plant. Okay, it has leaves, photosynthesizing leaves, but it also have spines that are protecting it from being eaten or damaged by some animals. Okay, it's just an ordinary plant that has photosynthesizing leaves, that the stem is not of green color because it's not the role of a stem to photosynthesize. Okay? And then, somewhere in the process of evolution, this plant lost its leaves. The stems became thicker and green. Okay? So the stems became thicker to store water for the time when there might be a shortage of water, but the stems are green because the plant lost its leaves. This species lost its leaves to prevent the water from evaporating, to minimize the surface area of the plant, to reduce the surface area of the plant, the area through which water could evaporate, but at the same time they retained the spines. Okay? And this plant has also aerial roots. It's an epiphyllum actually, because it is a plant that can also take water from the air. Okay? So it doesn't grow in extremely dry conditions. It grows where there are shortages of water, but it cannot stay without any water for a long time. And then, in the process of evolution, the spines became longer, thicker, and more sharp. Okay? And they lost, again, just like in the other plant, just like in epiphyllum, they don't have the ability to photosynthesize. The stem is the organ that photosynthesizes, that turns energy of the sun into glucose and into food and energy for the plant. But because these plants grow in extremely dry conditions, when there is plenty of sun, they became round or cylindrical in shape to reduce even more the surface area through which water can evaporate. And because water in a desert or a semi-desert is very precious, they developed structures that are designed to protect the plant for losing the water, either losing it to an animal that might eat it and steal the water by eating the plant. So these sharp needles, these sharp spines protect the plant from the potential animals, just like here. Or here is like a cage around of spines around the plant. Okay? And here there are spines that have hooks at the end, so that whatever animal would touch these spines, the spines would be hooked into the skin of the animal, and it will be very difficult for the animal to get rid of these spines. So it's a very effective protection against animals. At the same time, some of the spines became woolly, just like here, and the wool here or here, not the wool, the spines that are woolly has two purposes. One is to create some shade around the plant so that the sun doesn't scorch it, doesn't burn it. And the other is to prevent the insects to get through them. This wool is so thick that an insect can only walk over the wool, the woolly protection, the woolly armor, if one can say that, because it's so thick. And insects might also take advantage of the water that is stored in the body of the plant. Okay, and here, this actually plant lost its spines. It's an astrophytum. It lost its spines. However, it developed bumps all over it, and the bumps are protecting the plant from being burned by the sun. Okay, so from this plant developed all these plants through the very, very long process of evolution. But some of the plants, some of the members of the family Cactaceae didn't develop to be succulents, didn't develop to grow into extremely dry, extremely sunny conditions. Some of them went back to the environment where water is not scarce, where water is not really something that is limiting the growth of the plant. On the contrary, they grow in conditions where there is enough water, and they grow in conditions where the sun is not very bright, because these are epiphytes, which means these are plants that grow on tree trunks, and the canopy of the tree is creating shade above them. So they need to increase the area of photosynthesizing, but they cannot. They lost the leaves already in the process of evolution, so they cannot grow leaves anymore. So they flattened their stems. They made their stems, they made the surface area of the stem much larger, flatter, and again, the stems are green, and they took a role of leaves. Just like in these plants, the stem is photosynthesizing, but reducing the surface area in order to prevent the water from evaporating, and they have problem with too much sun. These plants made their stems flat in order to increase the surface area, in order to be able to trap more sun and to have the better ability to photosynthesize. And they don't really care about losing water because they have enough of water. Okay, and these leaves, these stems, actually, this is a Christmas cactus that doesn't grow nicely, and if you know why, please let me know. I don't know why, it just doesn't grow nicely for me. Anyways, these stems are very leaf-like. They are even thinner than here, okay, and they have a role of just leaves in an ordinary plant. And these are two rhipsalises that didn't make their stems, again, epiphytic plants growing on trees, they didn't make their stems flat, but they made them very thin. So again, the ratio of surface area to the volume of the plant is favorizing photosynthesis rather than preventing the plant from evaporating too much water, because again, there is enough water in the environment. There is another water in the habitat where they live, where they grow. Okay, so the same family of plants, that developed completely different strategies of growth and of adaptations. Okay, so the adaptation to extremely dry condition, and then they went back to conditions that were not dry at all, but they have to somehow deal with the fact that they lost their leaves. Okay, so you might ask why plants that are so very different are still treated as one family of plants by the taxonomists. Well, it's because of the flowers. Okay, all these plants have flowers that have the same design, the same pattern. Okay, you are very welcome. Unfortunately, I don't have cacti in bloom at this time, but you're very welcome to look at almost every cactus here on this table is somehow in one of my videos, and the flowers are of course not the same. Every cactus has a different flower, but they follow the same design. Okay, so because flower is the most conservative organ of a plant, it's the flowers that are taken into consideration when taxonomists are putting plants into groups, into families, into genera. Okay, so I really hope you find this video interesting. I hope you find this subject interesting. I find it fascinating. I really am very much interested in it. I really love learning and witnessing the way the evolution resolved problems that were on its path. Richard Dawkins actually wrote a book which is called The Greatest Show on Earth, and I think every plant and every living organism is a proof that evolution really creates the greatest show on Earth. And so do these cacti. Thank you so much for watching my video. Have a great rest of the day.